I'm Ron Noonan. I'm a product manager on the AI team.
And I'm Alex Festa, also product manager in the SUSE AI team.
Great. So we're going to go through observability, start about with the why do you need it, what it is. Then we're going to talk about what SUSE AI Observability is in the product specifically, what we're including and what and how to use it, where to get it, where to look for it, what components they're going to be for you to use, and then how do you leverage it in the environment. So we're going to go through all of that. We'll start with the why.
Yep.
Really, what am I going to say? We write down these things, they all sound good. This is kind of my take on observability with AI. And in the cloud native space, and you still have to do cloud native observability when you're doing an AI application, if it's a cloud native application. In cloud native, I get the sense a lot of people think of observability as kind of a nice to have. And when you're working in AI, it's not really a nice to have. It's really important that you have it. It's a must. Because it's so important in so many aspects about controlling the application. You cannot see what the application is doing. And we'll go through a couple of examples. An LLM is a bit of a black box, and the pieces it talks to and how it interacts with other things are very, very opaque. And with you need specific observability components. Boy, I can hear the difference. Specific observability components to actually drill into that so that you can gain the trust, the transparency, and then all those things become true. And that bottom one, like the optimization and the SLAs, you cannot keep an AI application running and or remediate it in any kind of quick fashion if you don't have some level of observability installed on the platform. Okay, I guess, you know what, I'm going to give this to you because
Give it to me.
it's bothering me.
Yeah, go for it. Just ask.
So, why is it needed? Okay, the complexity of AI systems, we'll go into that. They're really hard, they're opaque, and we'll go through an example. Drift and degradation, things, and some of this stuff is captured by observability, but how do you actually know if the model's drifting? How do you know if it's doing something different than you thought it was going to do? You did your tests, everything worked fine. Is it changing over time? You don't know. Observability doesn't necessarily tell you it's drifting, but it gives you the tools to find out if it's drifting. Compliance explainability, important things. Debugging and troubleshooting is absolutely critical. And I don't think most people normally associate observability with this being a critical component of needing to be able to debug and troubleshoot something. But in this case, it really is. So let's just and this is a really kind of simple application. You might have a chat bot or an automated application that's talking to an API that's interacting with your models. And you might type a prompt into that chat bot. And that prompt, it has different ways it can go. And ultimately, when it comes back, you get a response. It came back from the LLM. Great, it works. But what actually happened? Go to the next slide. So, the prompt, when you send the first prompt in, you might have some code there. And that code might say, well, this is the prompt, and it doesn't need to do anything but go straight to the LLM. And then you get a very simple prompt sent to the LLM. You know what the prompt is. The LLM answers that, and you get the response back. Or it might go, well, this is a prompt that needs to go to the system of the augmentation. So you might have a RAG implementation where you've got data, and it's going to send it down to that data. And, in this case, a vector database. It's going to do a search on that. It's going to get the return on that search. And then it's going to use that search return and use that as part of the prompt that it's sending to the LLM. So in that case, what gets sent to the LLM is actually entirely different than what you wrote in the chatbot. It is a unique, different thing. So if you go one more slide, that depending on what happens and what your application's designed to do, what interacts with the LLM and what set of tokens are associated with it and what the token responses are, is you don't know. You don't know. You cannot know. You could set up a test environment, and you cannot anticipate when someone writes a prompt, whether the search that it does on the vector database to do a contextual set of relationships, like give me information on the docs, maybe it's searching manuals on an application that you wrote. That if you wrote something that is throughout the manuals, it might return a very large set of data. And it will use that large set of data and send that in as the prompt. It might set something very small. The point is you don't know. And when it comes to not knowing those things, then you get into, well, what's the performance going to be like? How many tokens are going to be used?
Yep.
How much is this going to cost to run? And all of that becomes extremely variable. And if you can't look at what's actually happening as you build it and as you test it and as it's running, you'll never know why it's behaving the way it's behaving. So ultimately, because LLM applications are context-based and what the interaction with them can vary greatly, you really have to have a level of insight in there to understand what's going on. Okay, so why you need it? You need to understand when something's occurring. If you don't have it, you won't have the insight to remediate issues. If, for instance, I probably should have left a picture on this slide. If you're in one of those applications where it's doing a call to a vector database into a model or to another model, there might be multiple steps in there. You might have many things going on. If you don't have some level of insight, when that change maybe one day goes from 5 seconds to 25 seconds, you won't know where it happened. You won't know what happened. You need to be able to look at it. You need to be able to look at the token counts, the token queues, and all of the interactions between the components so that you can isolate what changed and where it changed, and so you know where to look. And then it's also really used to understand resource use. A lot of these systems are really expensive. Am I using it correctly? Am I using the resource well, or am I overloading them? Do I have some that are not running that are at max load and some that are? And this is interesting because when we get into the things that are actually tracked in an AI space, it varies a little bit from the standard world that well, at least what I was used to, which is CPU utilization could tell you kind of like, am I okay? Am I not okay? CPU utilization tells me if my node's running well and is it running at capacity. In this world, you can't just look at GPU utilization and say, am I okay or not? You have to start looking at tokens, token queues, response times for first token, and how fast it's chewing down the queue. You have to actually have insight into all of that to ascertain what's happening, what nodes really need to be duplicated and or running in a different fashion. And I'm kind of plowing through this. Yep. Do you have a concept or a comment?
Oh, sorry, no. Yeah, no, you're absolutely right. Because I was also add that in the nature of LLMs, we can have even further complexity. That is, for example, if you look at agentic workflows. So the agentic workflows is an agent that basically can instruct the LLM actually to leverage tools and basically consume other kind of sources in your company. That means basically that it's unpredictable because the LLM itself has to create a plan on which tools I should use, which sources I should consume actually to get a result. That means that I don't know upfront if it's going to connect to a database, or it's going to scrape the web, or it's going to, I don't know, use the IRP, depending on what the user actually prompted. And that's exactly what you were saying, Ron. That is like, I need to understand the where and why actually is occurring and where is occurring actually. Because from a user perspective, all you will basically see is like, oh, I just prompt something and I don't get a result. And I'm waiting there, and that's my problem.
So what is AI observability? This is, well, the table stakes. You always have operational observability, model observability, data observability, GPU monitoring. When we go into what actually that is, I guess the next slide will get there.
Oh, sorry?
No, it's fine. Is the table stakes are those bottom three, so in this semi-colorful picture. These right here are what everybody tracks. This is the standard stuff that you track in observability. Tracing the stuff that's long running, which spans microservices or steps. Metering, that's the metrics. That's all the stuff that you're actually tracking. And logging is logging. When we do AI tracking with observability, we're pulling all of those things in, and that's all being captured. SUSE AI actually then will add in one other step, which is it'll pull the Kubernetes topology in the cloud native environment, and we'll go into a little bit what it's doing and how it does, and then what it looks like when it's finished doing it. But it'll pull that topology in, and it'll overlay all of the AI metrics and infrastructure into the Kubernetes environment so you can see where things are, how they're running, and what's running in the environment, on what nodes, et cetera. and namespaces and the like. So what your platform should do. This is kind of the interesting part. With observability, any of these questions, you need to be able to answer them. So if I'm a machine learning engineer, I need to track latency and response times. I need to be able to optimize the performance. Data scientists might want to be able to understand the prompts and responses. The financial analysts track token usage and the costs associated with token usage, and we're just use token usage to understand chargebacks, even if it's internal. SRE receive alerts and want to take corrective action. They need to understand what they need to remediate and how they have to remediate. They need to know what's going on when and where. And you go through it. You can read it as well as I can read it to you. But so you go through this stuff. You need to be able to answer this stuff. If you go to the next slide, these are the things that your observability needs to track, so you can even answer those simple questions. There's a ton of stuff that needs to get tracked so that you can have those various views. And if you just kind of roll the next couple of slides, it's just like the logs and I just cherry picked a couple. Logs and token generation rates, super important to understand that stuff. Calculate and display the estimated cost per user and model. That's a common set of questions. People ask that a lot, like how do I get that? How do I understand that? GPU utilization, everybody asks that because GPUs cost as much as my car. And
oh, sorry.
That's okay. That was it. So, and then when we get into what we're doing, now we'll just talk about, okay, what does SUSE AI as a product bring to the table, and how does it actually help you do those things and track those items? So what we're doing with SUSE Observability is we're providing you the cloud native experience, which you have to have, because typically a lot of the AI apps will be a cloud native application. And it'll track all the stuff that's associated without the Kubernetes environment and the like. But then it's going to actually augment that and apply the additional infrastructure so that you can track the models, the GPUs, the vector databases, etc. To get all of that done, what we want to make sure we do is it easy to install? Is it easy to get these extensions and put them in place? What are the tracking systems, and how do you do it? Standard uses of auto instrumentation or custom. Where are the dashboards? Can I just grab them and install them so that I can see these additional components? And then what's monitored and how you actually can set monitor. Well, I'll talk about what monitors are later, and view over time. So those are two of the aspects. The first three are things that we're going to actually just kind of walk through, and then the last we'll show you in the demo.
Yep.
So easy to set up. This is where you can find things, and it's part of the overall SUSE AI experience. Alessandro, do you want to touch on this, and then later we'll show it?
So how many of you knows or recognize this image? Okay, just to, you can answer.
It doesn't count, I know.
You don't count. So this is basically Venture Prime page. This is where we offer what we call an application collection. So basically it's a collection of applications that we can offer to our Venture Prime subscribers. Within that, you have, if you basically have the SUSE AI, you can basically find every SUSE AI entitlements, including the dashboard from the observability. What we do here for the components and for the dashboard basically is an automated way to provide you in a secure context components. So if it is for components like Olama, for example, that is an inference engine, basically what we do is take the upstream project, embed the upstream project within a SUSE Linux container, remove all the security, the CVEs that we find. So we basically make it secure and ready to run in production or at the enterprise grade, still using the upstream project. When it comes instead to observability, the idea behind it is actually to leverage instead the simplicity of installation. So this way it's a one-click experience. So I don't really need to think about how to configure it, how to implement it, how to install it on my SUSE observability. I just need to enable it, and we go through. The other value, of course, is that every time we release a new version, in the SUSE AI, we are following a sort of a rolling release timeline. So it means things keep coming. We don't have a major or minor release. We simply, every time we finish one thing, we release it immediately. So that means that every time we release a new dashboard or a new capability of observability, you will find it here immediately, and you can start to use it immediately.
Yeah,
Oh.
jump ahead. So we're going to go through a couple of components, and I probably actually step back.
Yep. Sorry.
Just no, it's okay. I'm thinking about kind of the flow, and so what's showing here is kind of like a static picture, and we'll go up there and show you the live version of what this stuff is. But there's a couple of classes of components you're going to be able to find up here in April. They're not there right now. So in April, these things will be there. So if we go looking, you won't see it. April, all of a sudden, will show up. You'll see two classes of things. You'll see a set of auto instrumentation Helm charts that are language specific that you can grab that will instrument your application without having to do a modification of your application. You'll be able to grab those, run them as a sidecar, and then that will it'll generate the standard data and format of that data so that it can report into the observability dashboards. In addition to those auto instrumentation components that we'll be putting up there in a curated fashion, we'll have the custom dashboards that can then render and display these unique aspects of what it is. And we do have some alpha versions of that, and we'll be showing some of that in here right now. But those dashboards and those auto instrumentation components will be there with Helm charts, so they're pretty easy to plug into the environment. You have a Rancher environment, you grab those with SUSE AI, you plug them in, and all of a sudden you can see the aspects of what the AI infrastructure is actually doing. Okay, now we can go. Thank you.
Okay.
So the auto instrumentation example, this is straight from GitHub. There are multiple ways to instrument an application. One is you can write it yourself, and maybe you've got a Python app or a Go app or whatever you wrote it in, and you can write the instrumentation yourself to actually report what you want it to report for observability. But these systems are up there on GitHub that are kind of the accepted ways to automatically instrument your application without having to recode it. So say you already wrote an application, it's a Python application. You can go up there, you can grab one, follow one of these methods, and these will be on these SDKs will be up on our application collection. You follow one of these methods, run it as a sidecar, and then it'll actually report to the back end. So you tell it where your back end is, and you're pretty much done. It's very simple. Next slide. What's really going to happen then, and this is kind of in the product, and is what we're really doing, is we're using the OpenTelemetry agent inside as an addition. And it's pretty much what everybody uses. This is kind of the industry standard. And just so you know, I'll say it, OpenTelemetry is the single largest project right now in the Linux Foundation. This is not a small thing. This is really important stuff. Everybody's using it. It pulls the token stuff out of the LLM. That's the top right. It can go into a vector database. In this example, the Milvus DB is pre-instrumented. It's up on AppCo from us, and when you grab it, it's already instrumented and ready to report. And it can pull the NVIDIA operator GPU monitoring. Well, it doesn't pull. Yeah, it does pull. See, there's a push and it's a pull. But it'll grab those three areas. And the other thing it'll grab that's not depicted in this is it'll actually track every prompt that was typed in and every response that was generated back, so that you can do prompt response comparisons and actually compare them over time, which is kind of one of the tools that you will use to detect model drift. Go to the next slide. It just kind of shows the SO agent. So that's the SUSE Observability agent. That's what we use to track and monitor the cloud-native aspects of a Kubernetes environment. And it's pretty rich, and we'll go into the screenshots of what that provides in a second, and then the demo.
Yep.
But what we do with this, and this is the fun part, is we overlay all of that stuff coming in from OpenTelemetry and that agent with the SUSE Observability agent, so that you can actually look at the Kubernetes layer, at the services layer, at the namespaces and the like, and track it back into what is actually happening in the AI infrastructure and see what's happening where and why. Yeah. So then you get into screenshots like this, where you're looking at the topology. Yeah. And Alessandro, you're going to bring this up in a second. Yeah. Call out a couple of things here. I mean, you're gonna end up highlighting this, but when we get into a topology view, I mean, when you look at a topology view, how would you normally use it? And then when you have AI added to it,
Yeah, exactly. No, you're absolutely right. That's so. My main problem is, for example, that if I look at, without looking at these, in a topology, what I expect is actually to starting from a really high level view and then deep down up to the service. So what I want to see there is basically the connection that is being made, if the connection actually is working, and then basically how the service is related. And close enough, I'd like to be, for example, able to see if I'm using an embedding model versus an LLM model, if I'm using a chat service versus, I don't know, an API call, how this is basically instrumented, how basically it's related, and so on and so forth, and possibly get out as a result maybe the token count per user per service. So basically I can calculate the cost per user there. So those are the things that, from my perspective as a, let's say, AI practitioner, that's what I would expect a tool give me. But if I use OpenTelemetry, like you were saying, some of those can be more or less seen, but I don't, for sure, I don't have a topology, I don't have a view like this, and this is basically what is missing. Yep, no, I'm going.
Cool. Yeah, so this is a few of the screenshots from that we're going to do, but
Yep,
yeah, keep rolling.
yep,
And I think what we'll do is just dive into the product.
yep. Let me just deep dive into the product so this way you can describe it directly. Okay. I'm getting old. I don't see things. Sorry. So basically, so I'm starting from here and Ron will deep dive into that. So I already filter out a cluster, a namespace specifically that is a SUSE AI. So those are all the services and things. So these I think already show what Ron just said. If I look at this view, I have a lot of information, but I have no clear view about how things are working together. But if I switch on, if I switch on the topology, I start to actually see things. I can start to see how basically, for example, this is the Milbus database. It actually is related to the service, but it's also related to the various services. And then I can start to see that this is my host, is related to all the things. And for example, in those cases, I can say, for example, that I have an Open Web UI interface and I see Olama. And then I can start to deep dive into that. I can click on that and say, okay, show me from Olama perspective, that is my inference engine, what I want to see. And then you see that actually it show me how Olama is related to his own services directly, and then I can again explode that and start to deep dive into the topology. You see that I started really high and I started to deep dive, and basically from there, basically I can literally go there, and then I can basically start to see things that actually could be interesting for me, like the tensor core utilization of a model, or I can start to look at other nice things of the service. I was trying to explode these and go deep dive. Maybe I can just.
Those cool little squiggly dots flowing around are the connection points.
Yep, exactly. It will show you exactly. And when you click on the inside, it gives you exactly the relation between those things. Now it seems simple, but actually give you a simple way to view a complex scenario. And now you can basically deep dive a little bit more into what we were saying, that is the general observability. So I can literally go there and start to look at the things from directly from the system. Like again, we are on the Olama part here. I click on Olama and I immediately get to the dashboard. If you want to describe the dashboard.
Well, sure. I mean, essentially what this is doing is it's looking at the average token consumption on this particular UI or this particular dashboard. And what we're doing is, what we've done in this case is use the JSON service file in the background to assign what a token costs. And so when I do that, if I can set up, I can assign any cost I want to it. It's what anyone pays for a token, and or even for an internal chargeback. When you do that, then it'll actually take those token counts on any particular call or on average, or what did you do in a day? What did you do per user? What did you do in a namespace? You could do it, and you can find out what that costs. And it's interesting. It really is keying on tokens. Tokens are everything in this world, with an LLM. But we get the question all the time, how do I track costs? Well, the way you track costs is you track your tokens and you understand what your tokens cost. You can even have tokens where I say, it costs this much to this service and a different amount to this other model. And I might have a call that, like the one I did before, it went to a database to an LLM. It could have gone to an LLM and then to a different LLM, to a different LLM, and then come back to you. and I might have different token counts to each one and different costs with each one. You can assign that, and it'll provide you the information then, so that when someone did a call, you can find out what that call costs.
And again, even from that point of view, I can see now the topology from that specific component. So since we select Olama, now I can see, for example, the entire LLM architecture in one single view. I have Olama, I have my 2 RAG system. How many of you knows what RAG is? So RAG basically is a retrieval augmented generation. It's basically a way to say, okay, here's my sensitive documents. Here's my LLM. Dear LLM, please go there, read those documents, create an index of those a graph of those documents, put it in the vector database. So whenever I ask you something, instead of trying to figure out on your own, you will leverage that information and give me a contextualized answer. So it's really important to know how the inference engine actually work with the retrieval augmented generation. But the beauty of the SUSE observability is that I can literally expand and see each one of those relations. And basically I can see, for example, that right now I got Olama, this is the way it's connected to the RAG, this is the way it's connected to my model, in this case, yes, this one. Then I can expand it and I see that, for example, it's connected to a chat system. So I know exactly how it works. But if I go back into one of those RAG and try to expand them, they will show me basically that it's connected to, it will show me basically that it's connected to Milvus, for example. Oh, sorry. I lost control of my slide. That is, here it is, Milvus. And then I can click on Milvus and I can see, for example, the number of requests that have been mined Milvus, and I can explore the entire document, the entire component. So I can open up the, and then basically from here I can see change of configuration, the way they perform, the way actually is working, etc., request rate of the DB, and etc. And I see like what kind of operation you're doing, 3 general operation in this case. So I can, for example, click on that and see what are those things like recollection, like a query, etc. You see how it's simple like it seems. It's really like what you see is what you get in the end.
Yeah. So, let's just, I don't know if this is the best screen to do it, but let's just take one of the screens and show them. So right now, you see this down here, it shows you the time. So what's showing up here, whatever's up there, this is real time. It's actually tracking what you're seeing in real time. You can drag that back, and it's useful. You can go look at different states over time. So, and this is, I guess I'm supposed to do this.
Yeah, exactly. I'm just jumping back 30 days to see a specific event. So
yeah.
I can jump on these.
And that's really useful right there because, a lot of times what will happen, in the world of troubleshooting and remediation is maybe you came in on a Monday and something happened on a Saturday or Sunday and things are no longer behaving like they should. You can roll this back, and it doesn't just roll back and let you see the metrics, which is what most systems capture. In this world, with this product set, when you roll it back, everything that you saw live, you can still track and see topology-wise, tracing-wise, metric-wise, and logging-wise, all the way back to the time slices. And it'll let you then identify where something changed, exactly what changed, and what component changed, on what worker node and or namespace it changed. You can look at pretty much anything and then jump back to live mode when you want.
Yes. For example, I was finding randomly stuff, let's see if actually you can generate it. And basically I'm looking at Milvus, it showed if there was any error, there's any warning, and basically, well, there's no logs found there. But you see actually that I found something that was actually an event in the past that I can literally see there, and I can literally go to the event and see what happened there. And potentially that means also that, let's say that things was broken, instead of rolling back 2 weeks, 3 weeks randomly just because we need to put the system in a state where it was working, we can literally roll back just before the event just to avoid that configuration, etc.
We've had that asked for numerous times. People are they have a standard procedure. When something goes bad, they go back 2 weeks or whatever safe period is. So if we had enough observability, we could roll back to exactly before things failed.
And that's
and that saves them a lot.
And that's exactly what we were describing. This is the last change that has been done on that specific service. So I can literally go there and say, okay, I didn't find any other configuration. This is the demo environment, but it shows you the changes. You can compare the changes, and based on the comparison of the changes, you can decide what to do and who made the changes eventually. As well as show the status of a pod in this case, show the configuration of a pod. So we really can deep dive into that. Think about this in the context of an LLM system. So basically when I come here, I can literally say what it is. Olama. This is the inference engine. And I can see, again, the last change, and I also can see the configuration of Olama, literally. This is what is happening under the hood. I can change the configuration. I can, for example, put a new model, etc.
Can you go back to the section and bring up monitors?
The GenAI?
Yeah.
Which one?
LLM.
LLM? Okay. Yeah. You got the metrics. What you look at? Yeah.
So what I want to call out is when any of these systems, any of the metrics, any of the things that are measurable, you can set up monitors and tell the system if it goes below this value, or it is this value, or it goes above this value, set it as a failed state or set it as a non-failed state. You can tell it to do something. You can tell it to warn you. You can have it send you an email. You can have it send you a Slack message. You can have it send you a webhook. I mean, you can set up anything you want. And well, not anything, but it's got a number of things that it can do to warn you in these metrics, and then it'll bring up a remediation page. And we manage a whole set of standard monitors, and then the remediation pages that go along with them. So like standard kinds of events. When you trip one of these environments, we'll bring you to a remediation page that we keep populated based on the current technology and what's happening in the industry about what you need to do, where you need to look, and how to deal with it. We also let you create custom monitors. So you can put a monitor on anything you want, whether we wrote it or not. And maybe it's your application, you're tracking something, you did your own instrumentation, you want to write a monitor that tracks something that is completely unique to you. You can do that, it'll let you save that, and then you can actually write your own remediation page so that whoever's operating the system when that monitor kicks off will actually get the remediation page that you associate with it. So we supply a standard set, and we maintain those standard sets, but we give you the room to actually write your own and your own remediation guides that go into those monitors. And that'll attach to any of these standard cloud native components or any of the AI infrastructure components. That's pretty much what we wanted to cover, and I know we're early.
Okay. Thank you for listening to us. Hope we enjoyed the evening.